Good afternoon and welcome. I'm Bart Paulson, and I'm actually going to start by changing this immediately. There we go. I'm Bart Paulson, and it's the afternoon here in Salt Lake City, Utah, where I am joined across town by my friend and colleague and data scientist extraordinaire, Julia Silge. We're here to talk to you about data science programming, but also just a little bit of career stuff. Um, for those of you who are joining us live, we invite you to get into the comments and just say hello and tell us where you're coming in from. I will make a little banner right now that says that. Say hello, tell us where you are. Now, for those of you who are not here live, you just know we record this and it's available as video immediately after our session on LinkedIn, on YouTube, and Facebook. And you'll be able to access it through the same places that had the links to the live session. Anyhow, Julia, why don't we take just a couple of minutes and have you introduce yourself to us?
Yeah, thank you so much for having me, Bart. It's really a pleasure to get to talk to you. So, my academic background is in physics and astronomy. That's what I studied in undergrad and grad school, and I was in academia for a while, right? Like teaching and doing research. I eventually left academia and spent a few years like trying to really find my way after that. Like after I left academia, and I actually didn't go straight from academia to data science. I kind of was making like a path through like, what am I going to do now? And then I started seeing people who kind of had my background starting to get these jobs called data scientists, like roles with this. And I'm like, what is that? Like, don't all scientists deal with data? I mean, this was like 10 years ago. This was 10 years, like little over that. And I had not heard of someone with that title. And when I started learning more about like what they were doing, which was writing code to analyze data, working with data visualization, talking about like what questions can we answer with this data that we have? How have we thought about collecting this data? I really thought, wait a minute, that was like my favorite part of when I was doing, my more academic work in astronomy and astrophysics. I was like, all right, no, this is for me. Like this is for me. I love this like very applied real world, how do I live in this world of messy data and try to make decisions and unlearn things. I was like, this is for me. This is for me. And so that was about 10 years ago, and then kind of made this transition, which I'm very happy about how it played out. But I will say it didn't necessarily wasn't like without its bumps along the way, I would say.
I understand. You know, just for what it's worth, by the way, I want you to know that we do have a few people already saying hi. And
Oh,
even though
fun.
we are small, we already have an international audience. Let's see here. Here we go from Yehun in Texas and Vasco in Portugal and Tony in Long Island and Jean in Haiti and Ganesh, who's in Alabama, and Fernando in Brazil, and another person who is currently in Evanston. We tend to get an international group, but
That's great.
let me just mention this one thing here. You and I mean, we both predate
Yeah.
the um, data science as a field with actual training specifically in data science. My PhD is in social psychology.
Yeah.
Um, your degree is in physics and astronomy.
Yeah.
And I was mentioning to you beforehand, there seems to be this bizarre little pipeline from astronomy and astrophysics to data science. I mean,
Yeah.
there's a lot of people who have been very successful in data science who came from your background, and I'm wondering if you have any theories about that.
I do actually. So I think people who worked in the experimental side of physics and or astronomy astrophysics, which largely is observational in nature, really have a set of experience and skills that really lends itself to data science. And I'm going to highlight a few of them. One is like um, experience often with pretty like largish data sets for the size of computer that you have. I mean, when I think about how big the data was that I had when I was in grad school. It doesn't actually sound like that much, but at the time, Bart, it was a lot.
My dissertation had 199 observations, and that was considered large for my field.
Yeah. So often, like if you're working with a telescope, you get out actually like if you depending on how you count how big data is, right? Like you've with something that's computational pretty challenging because it's image data over a whole night of observation depending on how you slice up the night and whatnot. So I think there's the computational comfort with dealing with for what at the time you're dealing with it is fairly large data. I also think that something that is unique about a lot of experimental physics and astrophysics and astronomy is that you cannot do um like what you might call an A/B test or what you might call a classic experiment. Like you cannot be like these people took the placebo and these people took the drug and like what how did they do? Which does the drug work? Instead you are doing experimental or sorry, you're doing observational work. You're doing observational work and that is that really lends itself well to modern data science where you are like you're used to thinking about how do we keep ourselves from getting tricked? What are the approaches I can use to know if I can answer this question or not?
Mhm.
I do think people who work on like A/B tests, I notice often come more from the life sciences or from like clinical kind of spaces where they will have more of that background of like no I understand a lot about this group versus this group and how like how can I understand how much change it is? So I think the largish data and the experience with observational data and observational analysis and then just that experience of like real world data sure is messy and I have those skills around like dealing with that and being able to understand how to do that.
It just, I'm sure you remember, what was it, 2 or 3 years ago, the black hole observations,
Yes.
where they had so much data to produce their orange glowing donut. There's so much data that it was faster and easier to simply load it all onto hard drives and then fly it in an airplane
Yes.
to the main processing plant. And it was something like 500 pounds of hard drives or something.
It's incredible. It's incredible. That was so fun to see. I so the work back in the day, this is really going back now, but I did actually work on central supermassive black holes and galaxies. Like that was a big focus of my research when I was in astronomy.
Mhm.
Not the one at the center of our galaxy, but the ones in other nearby galaxies. So
They're
anyway,
easier to see.
yes, it's true. It's true.
Okay, I'm sorry. I now have the song "Supermassive Black Hole" going in my head,
Very
which
nice. Very
we're
nice.
off topic. Hey, I just want you to know we have a few other people joining us from Florida, Anna, and Connecticut, and Alexander, Sergio in Quebec, uh, Akamtua also in Canada, Renzo in Peru, and then Christopher in New York City. See, it's international. We've
For
got
sure.
roots.
For sure.
Now, somewhere in here, I have lost your there. No, we're gonna get back to where we want. Now, oh, folks, if you're logging in, even though I know we have these connections in the event announcement, I want you to be aware Julia has her own website, juliasilge.com.
Yes.
And I also gave a link to your LinkedIn profile,
Oh,
which
nice. Great. Thank
it's
you.
just
Yeah. Yeah. Thanks.
linkedin.com/n/Julia Silge. And I want to congratulate you for knowing how to take the numbers off the back of your
I'm
name.
really good at computers, Bart.
Okay. Speaking of which, let's transfer over to our stated topic today.
Yes. Yes.
Um, so if any of you out there are familiar with um, IDEs, Interactive Development Environment. Now, if you work in R, and I primarily use R, if you work in R, the best known one by far is RStudio, which used to be made by a company, which is made by a company that used to be called RStudio also, and then they changed their name to Posit. And that is where we come to you, Julia. So why don't you explain Posit and also the new IDE work that you've been doing.
Sure, sure. So I've been at, so I alluded to before, I made this transition into data science roughly 10 years ago, and a little more than that at this point now. And I was a working data scientist, but I really I also love R and love the R community. And I pretty early on discovered like open source software and the open source R community. And I was, let's say maybe there were 5-ish years where I would describe my life as like I was a data scientist, and then I built these open source tools on the side, like as many of us do, right? Like it was kind of like a hobby side gig kind of thing that I felt connected to the data science community. I felt really empowered being able to build tools that I and other people could use. So that was kind of what I would describe my professional life as for like a good 5 years. About 5 years ago, I was hired at then our studio, now Posit, and then I kind of shifted. So if before my time was spent maybe like 80% analyzing data, 20% building tools of various kinds, it kind of switched to where it's like, okay, now I'm 80% building the tools and maybe 20% analyzing data for.
Thank you for building wonderful tools.
Oh,
I and many others are very grateful to you.
thank you. That's really kind. That's really kind. I have known about myself for a long time that I really care about like process. Like I really care about how people do their tasks and like making that even back to when I think about, my time in astronomy, like I cared about how people were gathering the data, how can we, like how can we do all this? So I do like thinking about that and making those processes really great and like really smooth for people. So at our studio, which while I was there changed its name to Posit, when I first came there, I worked on the Tidy Models team. So that's a team that focuses on modeling and machine learning tools for R. I then shifted a bit like more like applied in the stack to model deployment tools. So working on tools like Vetiver and Pins that are about you've trained your model, you've trained it. Now what? Now what? Like, how do you actually deploy your models? That was really interesting for two reasons. One is that it was the first time I was working on software both for R and Python because we were building a pretty unified tool for deploying models that worked in both R and Python. And it also was super interesting to me as someone who loves R to kind of be in that space with that people actually say R is not good for. Like R is no good for production, or like R, like you can't put
People,
R in production, and like, well, actually, I've worked on tools that you can, and like, how do I make that work really well? So it was interesting for a couple of reasons, like really finally getting my hands wrapped around Python, that like also it is great, and then also thinking about R in production some.
I'm just going to interrupt for a
Yeah,
moment.
yeah,
One of the best things I read about Python a little while ago is a person said Python's a very clean and easy language to program in.
yeah.
That doesn't mean that the language itself is clean and easy.
you know
You got a
yeah.
lot of stuff moving in the background, and actually going straight to production from Python can be a real challenge.
Oh, 100%. No, working on
Yeah.
tools for putting things into production for R and Python,
Mhm.
it is very challenging in both. It is very challenging in both and takes a certain set of skills. So about 2 years ago, I shifted to working on a different kind of project. And at the time, it was a kind of like top secrets, kind of like don't tell anyone kind of project, and that was a new next generation IDE. So our studio, I bet many like I bet everyone who here knows what has used our studio, right? Like either you are an R person and it's your IDE of choice, or you learned R in school and then moved to Python in a job or something. Like probably I bet most people who are here or listening to this are familiar with our
And
studio.
if you've taken any of the four, at least maybe more than four complete video courses I've created in R, all of them have been in R Studio, including one that I revised very recently is getting edited and prepared for publication.
That's so exciting, and it is beloved. Like, and people are super productive in it. And I think there are a handful of reasons why. Like, why has it had the staying power it has? Why is it such a good fit? And I think, it's partly because many of the people who worked on it have excellent taste, have excellent opinions. It's also because it really acknowledges and embraces the fact that if you're doing data analysis, data science, data work, code first tools are better. Like, code first tools allow you to be more reproducible, allow you to collaborate more easily. Like, there are a lot of huge benefits to code first tools, and by that I mean in contrast with a pointy, clicky, GUI kind of tool. Like, it's better to teach people to write code than to try to make a tool that lets people do data science with no code. Like, you can make it so that people can learn to write code, and I think some of my most favorite tools, like the Tidyverse, are examples of this. It's like, it's better to make something so easy to use that people can get unblocked to write code than to try to make a tool that they don't have to write code. So code first, and at the same time, acknowledge people who are writing code for data science are different than people who are writing general purpose code. A
Yes.
data scientist writing code is different from a software engineer writing code. And it's not that they're bad or worse or like actually write terrible code. It's like, no, they're doing a different thing. They're doing a different thing. And
And
the
since
tool
you
needs
have
to acknowledge that.
engineer in your job title, you should explain this difference a little bit.
Yeah, yeah. So I think the real core difference is that someone who is writing code for data science is doing a more iterative thing. Is doing a more iterative, interactive thing where what you find, you then go back in this cycle of like, oh, okay, I found this, so let me do this now, and let me kind of like go through this. It like what I find impacts what I do. The other thing that is very different is that often you can't know what you're going to find ahead of time. Like, if a software engineer decides, I'm going to add a new button to the app. They're like, well, okay, I know how to make a button. I know about this app. Like, I can define what the success is, and I can be pretty sure I will be able to add that button to that app. Someone who is writing code to analyze data, it is possible that you might get answer A or answer B or no answer. You're at the end, it might be like, our data could not tell us the answer. Like, the data that we had. And that's like really different. That's really different.
What you're making, the image that comes to my mind, I had never thought of it this way before, is like the difference between an architect who says, this is the building, this is what we're making, it's going to be like this, versus an archaeologist who says, we're digging something up and we don't know what's going to be in there.
Yeah. So I think the people who originally started creating RStudio, the IDE, really believed this, that like code first is best, but that the work of doing data work, statistical analysis, data analysis, whatever words we're going to use for this, they are different, and that's fine. That's fine. And they need tools for it. And RStudio is, 15 plus years old at this point, like millions of users, super impactful. As time has gone on, there have been a number of things that have kind of come together for the company I work for to think about, what would a next generation data science IDE look like? Like, what would it mean for us to think about what the next thing would be for our company? And one big part of that is other data science languages. Like, the company that I work for did start out basically R only. Like the first tools that were made, the first big tool, like RStudio and Shiny, were kind of some of the first like big things. And then Hadley came on, Tidyverse, R only. But over time, we've come to see our mission more as like data science and not like specifically R. And so some of the projects that have been along these lines that have been really impactful in R, in Python, for Julia, like a big one was Cordo. Like, Cordo was one of these first big like multilingual things that filled a real need in some of like the non-R worlds, and allowed what had been learned in building, say, our Markdown. It's like, okay, what worked really well in our Markdown? Can we learn from that and then bring that and make something where we can have that in multiple places?
Just yesterday, I was making a video for LinkedIn and I'm talking about R. And we, I, confronting the perpetual question. People say like, well, should I be learning R or Python? And I say, the answer is both. Are you going to be a professional? You're going to learn both. If you're in marketing, you don't ask, should I be advertising on Instagram or should I be advertising on Facebook? The answer is both. And I can think of lots of other places. You know, you have to be a polyglot, and so it's beautiful to have a tool that embraces and facilitates that.
Yeah, yeah. Yeah, so my company started thinking about like, okay, what would a new IDE look like? What kind of thing would we want to make? And like, how could we think about making something that builds on like a sort of architecture that lets us be flexible about what languages people use and lets us solve some of the things that have always felt quite difficult to solve in our studio, things that maybe they would have wanted to do in our studio. So started working on this project, really excited. Really, it's really motivating, exciting, interesting, a lot of growth for myself personally in terms of like the stuff I've gotten to learn and new things I've gotten to try, in terms of like how to build something. And so this new IDE is called Positron, and Positron became public for beta users last summer
Mhm.
and is currently available for people to try out. And yeah, so I'm really excited. I brought some screenshots. Should I show you some screenshots?
Yes, I'm just going to do one very quick thing
Okay,
and say, folks, whoops, this is what we're talking about right here. Positron.
that's right.
Posit.co.
That's
All
right.
right, but screenshots.
Yes. Okay. So let me see if I can. Oh wait. How do? Oh no, I should have. There we go. Let's see. Oh dear. Okay, I should have done this. I should have done this earlier. Let me see if I can
Hold your computer up
allow
to the camera.
window, and I am going to. Okay, there we go. Is this working?
Not yet.
Not
Oh,
yet.
wait.
I
No,
think you just have to
I just
put
have
it.
to do this.
Okay, okay. All right, great. So this is a screenshot of Positron. And so the first thing I want to say about Positron, I'll say three things about Positron that we can talk about together. Number one, Positron is a data science IDE. It is an IDE specifically built for data science. So here we see someone who is writing a Quarto file. And so the source code is over there on the left. That's where you do your typing. And then on the right there is the rendered Quarto file. So Positron is not an IDE for general purpose programming. It is an IDE that is specifically for doing data science. And so that's the first thing that I want to say about it. The second thing I want to say about it is that it is built to be multilingual or polyglot. So here, if you look at this, if you're an RStudio user, a lot of this looks really familiar, right? Like there's like a source code where you write a source panel where you write the code you want to run, a fully interactive console, like a full featured, wonderful interactive console, somewhere where we can see like the variables we have defined, and a plots pane where I can like interact with my plots and do things. So if you come from RStudio, this looks really familiar. But what you'll notice is that we are running Python code here. We're not running R here. And so this polyglot, Positron has an architecture such that the front end features are focused on the task you need to do, and then there are these back end language packs that are like the engines for it. So if it can do something in R, it can also do it in Python. This actually has benefits even for our users. Like one of them, for example, Bart, have you ever had the experience of getting the bomb in RStudio, where like something
Yes, I have.
Yes.
Yes,
And the whole thing crashes. The whole thing crashes.
yeah.
So in a positron, if R crashes, the app all stays up and R just restarts for you. Like so these
Beautiful.
yeah, these architectural choices have benefits overall for all kinds of users here. So first, it's an IDE specifically for data science. Second, it's a polyglot or multilingual IDE. And then whoops, let me come back over here. The other thing I want to say is that there was work we had to do for R to make this work. Like a lot of the infrastructure that exists like for our a lot of it has been built by people at our studio, and Positron's architecture focuses on some of these like standards, like the Jupyter protocol. Like you're familiar with like many of you, I'm sure, have used Jupyter notebooks, which are like a way, and a Jupyter kernel is software that lets back end like Python or R talk to a front end. And so Jupyter kernel is most commonly used in a Jupyter notebook, but it's also a protocol that we have used to make the back end talk to the front end of Positron. So these reusable components, like if you're familiar with the debug adapter protocol or the Jupyter protocol, if you ever heard any of these, we needed to implement these for R. The great thing about this is that now these things exist and can be used in multiple contexts. So this screenshot shows someone debugging R code, where they are like, you can like step through and maybe find like where is a bug happening, or like what are the values as I kind of step through here. And you'll see that there's like debug variables. I can interact in the console with my debug session. So this is from this new Jupyter kernel for R that's called Arc. And because it's not a bespoke thing, but rather a these modern language protocols, they're actually reusable in multiple places. Like just as an example, like part of the Positron team has built a new formatter for R. It's called Air, and you can use it in Positron or R Studio or VS Code, which is pretty cool and exciting. So our like in making Positron, I feel like we're like bringing some exciting things to, say, the Python community, but also the process of building it has let us make these things that are like open source tools that can be used in the R community as well.
So, Julia,
Yes.
we have 2 minutes left.
Oh, okay. So I
Okay.
think I do want to say one thing briefly, and then we can wrap up.
Yeah.
Positron looks familiar, and it is extensible. And one of the reasons it's familiar is that the team making our studio uses it. The other reason it looks familiar is because it is a fork of VS Code. It is a fork of VS Code, and what that has a lot of benefits. It also has costs to us, like as a team, like we merge from upstream once a month, but it also means that VS Code compatible extensions work in Positron. So this screenshot here shows someone using extension that can be used both in VS Code and Positron. So that is, I think, an important thing for people to know about Positron here before we wrap up, that it is in fact a fork of VS Code.
Absolutely. And I'm just going to mention something that is, super elementary, but not everybody knows it. Folks, if you're out there and you weren't familiar with it, R is free. The language is free to download. R Studio is free to download, and Positron is free to download. I say this because I was dealing with I was getting some statistics data from the TIOBE index.
Yes.
And I came across an application I'm not familiar with, but apparently is really popular. But it's $1,000 a year
Yeah.
per person. And I just want to say, Julia and the people at Posit are doing this amazing work and offering it for free. You'll see that her company, her blurb there is Posit PBC. That is Public Benefit Corporation. And bless Posit for that.
Yeah, so I'll say briefly, like we do make pro products for people who have enterprise needs, and that's how we pay for all of this. So it's like we talk about it and we call it like the virtuous cycle. Like our open source products make it better to use, like to do data science, and that means more people want our pro products and pay us, and then we like kind of goes in a virtuous cycle. So that's how we stay sustainable as a business.
And not Bitcoin mining through
That's right. That's
right. So our time is up, and I want to thank you so much for joining me. I was just wondering if you have any closing words.
Yeah, I would say if Positron sounds interesting to you, I say go download the latest installer and just give it a try. You can find it at positron.posit.co. It is currently a beta product, so I would say be honest with yourself about how ready you are to deal with a beta product. But we really appreciate feedback from our early beta users as we see what does and doesn't work for people.
Absolutely fabulous. And I will now do this. Julia, thank you so much for joining me. And for people who are watching, just as a reminder, we've been recording this session and it'll be available immediately afterwards as a video on LinkedIn, on YouTube, and Facebook. And with that, Julia, thank you so much for joining me. And people who have logged in from around the world. I mean, I didn't show you, we had other people logging in from Malawi and from Pakistan.
Amazing.
It's
Amazing.
amazing. What you have is of global value. So that's fabulous.
Yeah.
And with that, folks, I'm going to press end and thank you so much for joining all of us.
Thank
Bye.
you.